So in this short video, I'm going to cover the basics, review the basics of what we've learned about the Pythagorean Theorem so far. And then I'm going to dig into the new concept that we're going to touch on tomorrow in class. There's going to be a quiz tomorrow as well, and this video should help you out a lot for that quiz. So this is definitely one sort of question you can expect to see on a DCA, the STAR, on a quiz I write. You'll be given one of these diagrams and they'll ask you for one piece of the diagram, whether it's a side length or the area of a square. In this case, it's find the area of the shaded square. Notice how this is 7 inches, and that is telling us the length of the hypotenuse. And this is 9 inches squared. So the fact that the inches are squared and that the term is right there in the middle of the box is telling you that this 9 square inches is talking about the area of this square. And this 7 inches without the square is just the length of the hypotenuse. So to find the area of this square here, you would just square 7, and now this is 49 inches squared for all this area in here. And then the Pythagorean Theorem tells us that a squared plus b squared equals c squared when we want to find a missing hypotenuse, but here we want to find a missing leg. So c squared minus a squared is going to equal b squared. That is the area of this square minus the area of this square gives us the shaded square. So real easy. Nobody has been having any problem with that so far, or at least the number of people having difficulties seem to be few and far between. 40 inches squared is the area of that square. Now next we're going to take that same idea and just simplify it a little bit. Your calculator is going to be very handy, and I'm just going to do number 8 here because it's a little bit intimidating with the decimals. 2 things you might want to do. First, always identify if it's a missing hypotenuse problem or a missing leg problem. The hypotenuse is the line that is opposite the right angle, and it is always the longest side. And the legs are the lines that intersect together to make the right angle. So this is a missing hypotenuse problem, which means we're going to be using a squared plus b squared equals c squared. And I'll give you a couple of options here. One, we can just go to the calculator and say 4.2 squared is 17.64. And you can make a little note of that as the area associated with that side length. We can do 13.2 squared, and again, make a little note of what we find, 174.24 for the area. Then we can add those two areas and take the square root, which is this plus this, and the area associated here would be 191.88, and then take the square root of our answer to get C is about 13.85. Now your other option is just to go to the calculator and do it all at once. The square root of 4.2 squared plus 13.2 squared, and you will see here on the calculator that that is going to produce the same value. So we're just giving all of the work to the calculator to do there. So learning how to really proficiently and effectively use your calculator is going to be very important for the big picture of my class this year. So that was a missing hypotenuse problem. Let's do a missing leg problem before moving on. We know this leg is 8, so the associated area is 64. And here, 11.4, probably want to consult the calculator on that one, 129.96. And we want the difference of those two areas and the square root of those difference because this is a missing leg problem. So we're using c squared minus a squared or b squared equals the other square. And again, I'm just going to practice using this technique. The square root of the hypotenuse square minus the leg square will give us this missing side length right here. So whether that's A or B is hard to tell because they're very close. Looks like it's B because it's just slightly longer than this side here. Well, the missing side is 8.12. All right. So that is a review of what we know. Also, one more thing. Let's review this application of the Pythagorean converse. Here we're given three side lengths, A, B, and C. So short leg, long leg, and hypotenuse. And then we just want to know if that could make up a right triangle, yes or no. So we plug it in to the Pythagorean theorem and have a look. This expression may be true, it may not be true. 6.5 squared plus 7.2 squared. So this left side of the equation is 9.409 and 8.9 squared is only 79.21. Those values are not equal, so not a right triangle. And if you just put an X or say no or false in either one of those is just fine. So what I think I'll do is I'll make this the review video for the quiz tomorrow, and then I will, let's see, tell you what I do. For those of you that are actually watching my videos, I will give you a little teaser. There's one problem on the quiz tomorrow that's a little bit new that you haven't seen, and it's a replica of a star problem. So let's say we had this situation right here, and this is something that is yay tall. And maybe we know this little chunk right here is 3 feet tall, and maybe this is a ladder leaning against the side of a building, and so there's 3 feet here, and maybe we know this is 12 feet, and maybe we know that the ladder is 5 feet away from the wall. So the question is, how tall, or what is the length of this line here? So it's a pretty simple application of the Pythagorean theorem. This would be 144 feet squared, and this one right here would be 25 feet squared. And because this is a missing leg problem, we would be subtracting those two. So 144 minus 25, let's see, 30, 14, 9, 1, 119. So this length right here is going to be the square root of 119, or about, that's a little bit less than 11. 10.91 after rounding. So that you know how to do, but then the question is, how tall is this whole thing right here? What is the total length of this line, which is the sum of this little 3-foot portion and this segment right here found with the Pythagorean theorem? So the correct answer to this question would be 13.91 feet. So you're definitely going to see a question a lot like that on the quiz tomorrow. For those of you watching my videos, this is my gift to you. Remember, if you like my videos and you want to see more, please like, comment, and subscribe.